In this video, we are going to review transformations of graphs. Our general equation given here, y equals a f at k times x minus c plus d. The a value is our vertical stretch. So if a is greater than 1, the graph is going to be expanded. If it's between 0 and 1, then the graph is compressed. If the value is negative, it means that it's reflected in the x-axis. Our horizontal stretch or compression is our k value. If k is bigger than 1, the graph is compressed. If it's between 0 and 1, the graph is expanded. And if it's a negative value, it is reflected in the y-axis. Two others, we've got our c value, which is our translation horizontally. If the sign is negative, it's going to shift to the right. If the sign is positive, it's going to shift to the left. Finally, our d value is our vertical translation. If d is bigger than 0, the graph is going to shift up. If it's less than 0, the graph is going to shift down. Let's just fill in these blanks here then. The a affects the graph y equals f at x by stretching or compressing vertically by a factor of a. If a is negative, then there is a reflection about the x-axis. The c affects the graph y equals f at x by translating horizontally c units, and d affects the graph of f at x by translating vertically d units. The k value is going to affect the graph of f at x by stretching or compressing horizontally by a factor of 1 over k. If the k is negative, there's a reflection about the y-axis. Remember, there is an order to transformations. First, you are going to stretch and compress. That would be your k or your a values. Next, you are going to reflect. That is if a or k is negative. And finally, you're going to translate. So moving horizontally or vertically. Okay, so these are going to be your c or d values. You're going to do your a and your k values first. Graphing the easy way. You want to start by graphing the base function. You're going to do your stretches and your compressions. Those are going to be your a and your k values. You're then going to translate your c and your d values. What I want to do is show you 3 examples, and then I'd like you to continue with the examples in your notes. The first, y equals negative 2x squared. We first want to identify what our base function is. So our base function is y equals x squared. We have a negative out front here. This is a negative a value, which means we have a reflection in the x-axis. And our a value is 2, which means we are vertically stretching by a factor of 2. Start with your base function then. So you should graph that out. We've got, just do a couple points here. There is our base function, y equals x squared. Get into the habit of labeling your graphs right away. And then now we want to vertically stretch by a factor of 2. So we're going to take our points and vertically stretch them. You're essentially taking your y value and you're multiplying it by 2. 0 times 2 is just 0, so our point at 0, 0 is going to stay the same. If we take this point here and multiply 1 times 2, that'll give us 2. So our new point's going to be up here. And then 4 times 2 is going to give us 8, so it's going to be way up there. Same here, the 1 again times 2 would give us 2. 4 times 2 would give us 8, so it's going to be way up here again. This is our first part of our transformation, is that we vertically stretched it. Now we need to reflect it. Reflecting it in the x-axis, we're going to just bring everything below the x-axis. So this point at negative 1 and 2 is going to be now negative 1, negative 2. Our final graph then would look like this. So this is our y equals negative 2x squared. Next example, our root function is just y is the square root of x. We have a c value of 2, and it's a positive 2, so that means we are going to shift to the left by 2 points. Start with your base function again, the square root. If we take 4, we would have 2, so our base function is going to look like this. And then what we want to do is shift each of our points left by 2. Taking the point at 0 shifts over 2. Point at x equals 1 is now going to become at -1. Shifting this by 2 goes here. For a transformed function, the one graphed in red, this would be the root of x plus 2. The last example, our base function would be y equals x cubed. We have a d value of -3, which means we're going to shift down by 3 units. Let's start with our base function then. So 0, 0, 1, 1, 2, and 8, so that would be way up here. So it's going to look like so. That is y equals x cubed. That means we're going to shift each of our points down by 3 units. So this point here comes down by 3, the point at 0 comes down by 3, point at 1 comes down by 3, point at 8 would come down by 3, so it'd end up at 5 here, just to give us an extra point. Connecting our dots, our graph would look like this. So this would be y equals x cubed minus 3.